Okay, team. We're going to talk a little bit more about parallelograms, and we're going to talk about how to prove that a quadrilateral is in fact a parallelogram. So here in the notes for 6-3, it says, is a quadrilateral a parallelogram? There are actually 5 ways that you can confirm that a quadrilateral is a parallelogram. The images show here display that, and there are words to accompany. If both pairs of opposite sides are parallel, as indicated by the parallel arrows, then the quadrilateral is in fact a parallelogram. Second way, if both pairs of opposite sides are congruent, then it's a parallelogram. Third way, if both pairs of opposite angles are congruent, then it's a parallelogram. Fourth way, if the diagonals bisect each other, as shown here with the slashes, then the quadrilateral is a parallelogram. And the fifth one. If one pair of sides is both congruent and parallel, then the quadrilateral is a parallelogram. So keeping those right there in front of you, let's look down at these exercises. Can you prove that a quadrilateral is a parallelogram based on the given information? Explain. So for one here, it says, it shows that both pairs of opposite sides are congruent. And that was our second reason right there. So we can go ahead and type that out here. So we're going to say, yes, both pairs of opposite sides are congruent, so it is a parallelogram. Okay. On to, this shows one pair of opposite angles congruent, and that's not enough. That's not enough here. Okay. So we're going to say, no, not enough information to prove it is I'm going to put parallelogram way over here. Parallelogram. Okay, and then the third one we have, this is actually this fifth situation here. We have one pair of sides, both congruent and parallel, so we can say, yes, one pair of sides is both congruent and parallel, so it is a parallelogram. Okay. For 4, we are shown that the diagonals are bisecting each other, so this is also a strong yes. Yes, the diagonals bisect each other, so it is a parallelogram. Okay. On 5, we have opposite angles, 2 pairs, both pairs of opposite angles congruent, so this one too is a yes. Okay, I have room down here. Yes, both pairs of opposite angles are shown congruent, so it is a parallelogram. Okay. And 6, this is our situation at the very top here, where both pairs of opposite sides are parallel. Okay, so this 2 is a yes. Both pairs of opposite sides are parallel, so it is a parallelogram. Okay, all right. So 7 through 10 says determine whether the given information is sufficient to prove that the quadrilateral is a parallelogram. So on number 7, it says that YW bisects ZX. So we know that one of the diagonals is bisected, but we don't know about the other one. Okay, so this one's going to be not enough information also. So for 7, not enough info. Only one diagonal bisected, and we need them both. Okay, so 8 says that WX is parallel to ZY and WZ is congruent to XZ, but we would need one pair of sides that's both. So this one also is going to be not enough info. Needs to be the same pair of sides. That would have to be both parallel and congruent. Both parallel and congruent. Okay. And number 9 says that VZ is congruent to VX and WZ is congruent to YZ. WZ congruent to YZ? No, this one's all over the place. Not sufficient information. Parallelogram. Okay. All right, so 10 says that angle VWZ is congruent to angle VYX, okay. And it says that WZ is congruent to XY. So that's not one of our situations. I'm going to say not enough info on this one also. I mean, there's all kinds of information that you can prove. You know what? I'm rethinking that one. If angle VWZ, and I'm going to mark this one, because there is something here that you can use. If angle VWZ, which is this angle right here, is congruent to angle VYX, which is this angle right here, those are alternate interior angles. When alternate interior angles are congruent, lines are parallel. So that tells us that WZ is parallel to XY. Okay, so yeah, this one's going to be a yes. Okay, so we need to make some notes here. Since alternate interior angles are congruent, lines are parallel. It also shows those same sides congruent. So yes, it's a parallelogram. I'll get there eventually. Parallelogram. Almost messed that one up. Thank no one for catching that. Y'all probably caught it though, didn't you? Y'all probably getting ready to say, Miss Burnett, it's wrong. Okay, so it shows us that WZ is congruent to XY, so those are also congruent. This one is actually this last situation right here. If one pair of sides is both congruent and parallel, then it is a parallelogram. Okay, so that one was a yes. All right, so I should probably go back and make sure I didn't make another mistake here. But I don't want this video to be really, really super long, so we do want to get into the guts of using algebra to solve some problems, and we got 6 down here, so let's move on. For what value of x and y must figure ABCD be a parallelogram? Well, if it's a parallelogram, opposite angles are congruent. So 2y would equal x, and 5y plus 54 would equal 4x. And that's what that tells you here. So you can use these two expressions to solve for x and y. And this is back what we did on 6.2 also. So 5y plus 54 equals 4x. So since x equals 2y, I can substitute this 2y in for x here, and now I have an equation with just y's in it. I can simplify and solve for y. And then once I have y, I can substitute that back in for one of those equations, original equations, and solve for x also. So for ABCD to be a parallelogram, x would have to be 36 and y would have to be 18. And I do suspect that we're going to have something like that to practice here in just a second. Maybe not quite that in depth, but we do have this really great example here. So this says for what value of x must the quadrilateral be a parallelogram? Well, if opposite angles are congruent here, then on number 11, we would know that 4x must equal 3 times the quantity x plus 6. I think that's a plus. Or is that a minus? It's kind of hard to tell. It looks like there's a shadow. So we're going to say plus and see what happens. Okay, so I would need to start by distributing. I'm going to distribute my 3 through both terms in the parentheses. Okay, and then I've got 4x still on the left. And on the right, I've got 3 times x, which is 3x, and then 3 times 6, which is 18. Oops, plus 18. Okay, so my last step then would be to subtract 3x from both sides. And that would give me 4x minus 3x is x on the left side. On the right side, 3x minus 3x cancels out, and I'm left with just 18. So 18 is the value for number 11. That would have to be true in order for the quadrilateral to be a parallelogram. 15 is the exact same type of problem, so let's go ahead and do it. 5x would have to equal 3x plus 28. So I'm going to group my like terms and subtract 3x from both sides, which is going to give me 2x on the left, and on the right, 28. So then divide both sides by 2, I get that x equals 14. Okay. I'm going to go ahead and do the other odd problem since I seem to be working the odds in purple. I wonder what happens if I make these bold. Will that look better? Just might. But probably only if it's something that I'm actively typing in. Okay. All right, so for number 13, opposite sides are congruent. So I would need to set a couple of these equal to each other. So let's do that. Let's set 3x minus 3 equal to, equal to 2x. So then all I need to do is subtract 3x from both sides, which is going to give me negative 3 equals negative 1x, and then I just need to divide both sides by negative 1, and that's going to leave me with 3 equals x. Now, since x is the only variable here, I shouldn't have to work the other pair, but let's look at it just to make sure, okay? The other pair is that x plus 9 equals 3x plus 3, okay? So for this one, if I subtract x from both sides, then on the left side I've got 9. On the right side I've got 2x plus 3. So my next step would be to subtract 3 from both sides, which would give me 6 equals 2x. Divide both sides by 2, and yes, x still does equal 3. So x equals 3. Final answer on number 13. We have 3 more problems. I'm going to switch over to some red here. Okay. Opposite sides would be congruent. So 2x would equal x plus 3. 2x equals x plus 3. So all I need to do here then is subtract x from both sides. And on the left side, that gives me x, and on the right side, that gives me 3. That's a common answer here, isn't it? X equals 3 a lot. So on 14, same exact concept. We have opposite sides congruent, so 2x minus 5 is going to equal x plus 3. So my first step here would be to subtract x from both sides. So on the left side, I've got 2x minus x, which is x, and then I'm going to bring down my minus 5. And on the right side, x minus x cancels out, and I'm left with 3. So my last step here would be to add 5 to both sides. So on the left side now I've got x, and on the right side 3 plus 5 is 8. Okay? So one more problem here. I've got, a decimal. Good times. 4x equals x plus 16.5. Okay, so my first step here then is going to be to subtract x from both sides. And that leaves me with 3x equals 16.5. And then I'm just dividing both sides by 3. So I am actually going to show this because this is a lost art and I don't want to miss out on this opportunity. Dividing both sides by 3. So I've got 16.5. Call everybody in from the family to watch this one, everybody. Longish division. 16.5 divided by 3. Okay, 3 doesn't go into 1, but it does go into 16. How many times? Goes in there 5 times. Then you're multiplying. 5 times 3 is 15. And subtract. 16 minus 15 is 1, and I'm bringing down my 5. What do I do with that decimal point? It's going right up here in the answer. And 3 goes into 15 5 times, and if you want to, for good measure, multiply again. 5 times 3 is 15. And you're subtracting. 15 minus 15 is 0, and everybody's happy. So we have that x equals 5.5. Finally, a good decimal answer. Because it's the holiday season, let's go ahead and switch over to green and circle our answers. Okay. So I've got that x equals 18 here. Ooh, that is pretty. I've got x equals 3 here. X equals 3 twice here. Let's circle one of them. Over here, x equals 8. I think I do like that bold type better. And then x equals 14 here. And our wonderful decimal answer here, x equals 5.5. All right. I hope this has been helpful to somebody. I'm going to save this and upload the video, and we'll go ahead and get these going, and then hopefully we'll be able to have time to come back and record the next two also. So thank you guys so much.